Tutorial sheet 1, question 15. We're given this function x of t, which has an amplitude of a and is periodically repeating every t seconds, and we're asked to work out the Fourier series of this. So the Fourier series is given by this equation here, which is a naught plus this infinite sum of an times cos and omega naught t plus bn sine omega naught t. And omega naught is 2 pi over the period t of that function. And I've given the equation which defines a naught, an and bn in terms of the function f of t and an integral over the period of that function. So what we need to do is determine these values. Well, a naught is actually very, very simple because it actually just works out to be the average value. And the average value here, because it is periodically repeating, is just a over 2. So that's nice and simple. We're left with dealing with an and bn. Now to do this, we can simplify this process by determining whether this function is odd or even. Now, because we have an average value associated with it, it may not seem too obvious whether this is an odd or even function. So what I'm going to do is replot this function, but taking away the average value. So I'm going to plot x of t minus a over 2. And what we have in this case is a function that goes both above and below the axis. And here we can quite easily determine whether this is odd or even. And in this case, because we've subtracted a over 2, the amplitude now is a over 2 or minus a over 2. And so if we look over the periodicity t, we can say quite simply that this is an odd function because x of t is equal to minus x of minus t. So this is an odd function. And an odd function means that an is 0 in this case. So what we're left is determining bn, and because it's an odd function, bn is now twice the integral from now, rather than minus t over 2 to t over 2, it's 0 to t over 2 of 2 over t times f of t sine n omega naught t dt. Well, our f of t is just over this period is just a over 2. So that simplifies to 2a over t, the integral from 0 to t over 2 of sine n omega naught t dt. And hopefully everybody should be able to integrate this function. So bn is equal to minus 2a over t multiplied by t over 2 pi n. Otherwise, we're remembering that omega naught is 2 pi over t multiplied by cos of n omega naught t between the limits of 0 and t over 2. Now you can work this out mathematically very easily, and I'll leave you to do that yourself, but essentially what happens is that bn becomes 2a over n pi after some mathematical manipulation of this equation. But this only occurs when n is an odd value. For even values of n, Bn goes to 0. So if we use the value of Bn and we put that back into our f of t, our final equation is that x of t, which is our function we're trying to approximate, is equal to a naught, which is a over 2, plus the infinite sum of n is equal to 1. Remember, they have to be odd numbers, of 2a over n pi multiplied by sine of n omega naught t.